In this next section, we'll be discussing wiring methods specific to cables and raceways, boxes, and enclosures. We'll start this section for wiring methods, cables, and raceways with some general inspection requirements that project inspectors are going to be fulfilling. One of them is verifying proper raceway conduit fill. And there are some supplemental references within the California Electrical Code that project inspectors can take advantage of and refer to if they need to. Those are located in Chapter 9, Table 1, and also the Annex C tables. But I want to caution project inspectors to not rely on these tables in the performance of their inspections. It's important to understand that the design professionals use these tables to make sure that they are providing the correct code compliant designs in the drawings. So these can be used by project inspectors simply as a reference if you have a question as to whether or not a conduit is overfilled. But again, I just want to caution you that tables are primarily for design professionals. Another check or inspection the project inspectors are going to perform on electrical, which is general in nature, is verifying that no more than 360 degrees in bends exist between pull points in any number or any one run. This information is verified and reiterated in a variety of places dependent on what the type of conduit being used as the raceway is. And we've shown a few of those here so that you can pick up on the pattern that develops. For IMC, that information is reiterated in Article 342.26. For rigid metal conduit, the information is found in Article 344.26. For EMT, the information is found in Article 358.26. So I think you see what the pattern is developing here. Depending on what the type of conduit is, you will look under the .26 article for that conduit for verification that the number of bends in any one run must not exceed 360 degrees. You're also going to be verifying the suitability of raceway locations. Suitability meaning the environmental conditions that the raceways are approved for use in, such as dry, damp, or wet locations, etc. This information is found in Article 314.15. You're also going to be verifying that the required separation between, say, standard power and lighting, class 1 and non-power limited fire alarm circuits, conductors, and also MP-NP-BC cables, which stands for medium power network powered broadband communication cables. All of these types of cables and wiring are required to be separated from class 2 and class 3 circuits. This direction is also provided in Article 725.130. Additionally, it's important that you ensure that the contractor uses the manufacturer's recommended tightening torque values and also a calibrated torque tool whenever they are tightening lugs, etc. This information is reiterated in Article 110.14b. This slide depicts a partial view of a power floor plan from a DSA project. And what do we want sounding in our heads right now whenever we see a picture of a drawing or a plan? Read and review every word and every symbol on every plan and specification sheet for every project always. And again, it's very important because there is so much valuable information located in these pictures or these drawings on the plans. There's general information such as the room names and ID numbers. There's general notes. There are details. There's also additional views. For power distribution components, there's a variety of important pieces of information as well. Say with respect to conductors, the quantity, the types, the sizes, and the general routing for conductors is provided. For conduits and raceways, the size, the locations, the general routing, and also home runs are indicated. For junction boxes, switches, and receptacles, the location, the type, and any protection is provided in the drawing. For equipment and appliances, the types meaning as they relate to various schedules, mechanical, electrical, and plumbing schedules, the location, the circuit landings, and the disconnects are provided. With respect to panels, the panel name, the ID number, and the locations are all shown on these drawings. So it's essential that a project inspector reads and reviews every single symbol on these drawings. And it may be useful as well in situations where you have a lot of side notes to use colored pencils to coordinate the actual notes with the symbols that are reflected on the drawing for a quick reference. This slide just reiterates all of the information that we just mentioned looking at the previous drawing from that project. And again, it's so important because there is so much valuable information crammed into each one of these drawings that you must read every single word and every single symbol. Again, what it does is it continues to help you as a project inspector paint a clearer picture of the entire project as it is intended to look when it's completed. Again, read and review every word and every symbol on every plan and specification sheet for every project every time. This is a lighting floor plan taken from a DSA project. And again, similar to the power floor plan we just looked at, there's a tremendous amount of very important information that's provided on this particular sheet. General information, again, room names, ID numbers, notes, details, and additional views are referenced on this sheet. There are lighting system components, specifically conductors, which identify the quantity, types, sizes, and generalized routing intended for the conductors. For conduits and raceways, the size, locations, home runs, and generalized routing are indicated. For junction boxes and switches, the location and the types of each are indicated. For luminaires, the types, again, as they relate to the light fixture schedule, the location, and the circuit landings are noted. For panels, the panel name and ID number, and also the generalized locations for panels are indicated on this sheet. This slide again reiterates all of the topics and the issues and items that are noted on the lighting floor plan, specifically the sheet that we just looked at, but more generally any lighting floor plan sheet. We're going to talk a little bit now about protection of wiring methods from physical damage. Cables such as type NM, non-metallic sheath cable, type AC, which is armored cable, or type MC, which is metal-clad cable, whenever they're located within 1 1/4 inches of the wood framing edge, require a 1/16 inch thick nail plate, or basically a steel plate. This protection is required to keep fasteners from penetrating the conduits within 1.25 inches of the edge of the framing member. This is reiterated in Article 300.4. However, raceways such as RMC, which is rigid metallic conduit, IMC, which is intermediate metal conduit, RNC, which is rigid non-metallic conduit, or EMT, which is electrical metal tubing, do not require nail plates. And the reason is those particular types of conduits are rounded, and the fasteners have more of a tendency to glance off of them and are not inclined to penetrate them. Here's a couple of photographs from a project that show some metal-clad cable that requires nail plates. The image on the left, you can see the metal-clad cable is passing through a hole that's been bored in the actual wood stud, and you can see by looking at the tape measure that it is certainly within 1.25 inches of the edge of that 2x4 or 2x6. The image on the right shows a condition where the MC cable is running parallel to the edge of the framing member. It's not captured within a hole or a notch. However, because it is still within 1.25 inches of the face edge of the stud, it does require the nail plate. Again, this protection requirement is reiterated in Article 300.4, A1 and 2, and also D. Similar to wall framing, whenever raceways and boxes are located on roof decks, they are also required to be located 1.5-inch minimum from the bottom of the lowest part of the roof deck. This is required per Article 300.4E. And again, the reasoning for this is in an attempt to make sure that any roofing fasteners that would be penetrating the steel deck would not be penetrating the conduit or the actual boxes located underneath the roofing deck itself. Rigid metal conduit, intermediate metal conduit, and EMT are not required to comply for the same reasons that we previously stated for the wall framing, and that is that they are rounded and the fasteners will have a tendency to glance off of them and are not inclined to penetrate those particular types of raceways. Luminaires are also required to have the same 1.5-inch minimum clearance from the bottom of the roof deck. This requirement is located in Article 410.10F. Some more protective measures that need to be employed are protection against chafing of the insulation on conductors, particularly whenever raceways are containing number 4 AWG size and larger insulated conductors. They require an insulated fitting, such as a bushing, when they enter the cabinet, the box, the enclosure, or the raceway in order to protect the conductor's insulation. This requirement is found in Article 300.4G. Also, raceways exposed to different temperature gradients or where condensation is actually known to exist must be sealed to prevent potential condensation. That is, prevent the circulation of warm air to the colder section. This is expressed in Article 300.7A. Take a careful look at the picture on the right-hand side. You can probably clearly see that water moisture has condensed or has collected on the bottom lens of this particular fixture. This is basically the result of the contractor not properly sealing the interior of the raceway that feeds this particular fixture. And obviously the raceway is exposed to a wide range of temperature variations. And this picture is taken inside of a walk-in cooler at a school. This is the exact thing that you want to try and avoid by sealing the conduits where you've got severe temperature gradients existing. Another obvious part of protecting wireways and conductors is to make sure that the raceways themselves are securely fastened, and that goes the same for cables, boxes, etc. And they've got to be fastened independent of suspended ceilings for sure. What we see sometimes is that any type of support wire that's existing in a suspended ceiling is sometimes used by any number of trades for fastening their components to the wire as a quick fix. However, we all know that the support wire is used for support for any electrical components, must be sole purposed and secured at both ends. This is reiterated in Article 300.11 A and B. Additionally, another component of protecting raceways and cables is to make sure that whatever materials are used in certain areas do not enhance combustion. Electrical installations are not permitted to substantially increase the products of combustion or the potential for fire spread. It's one of the main reasons we see smoke development index and flame spread indexes identified on components. Fire stopping is required at penetrations, at fire resistant rated construction, and it's important that the CBC and the California Fire Code requirements are respected in all situations where penetrations are made through all fire resistant rated construction. In addition to the California Building Code and the California Fire Code, numerous additional references which are helpful to project inspectors relating to mitigating the spread of fire or products of combustion are available for reference, such as fire-resistant directories and product listings. These references contain listed materials and assemblies and also methods for construction which address mitigating mitigating fire in situations where fire-resistant construction is being penetrated. It's important that the project inspector ensures that only listed, tested, and certified code-compliant fire stop assemblies are installed. UL systems are most common, and they're most commonly referenced on DSA-approved plans, but there are other references such as WH Intertech, etc. It's also important that project inspectors review any certifications that fire stopping installers have and make sure they're applicable and current. These two photographs show some examples of different types of fire-resistant enveloping systems, such as fire putty pads on the left, fire caulking, and also the marking that's required on fire walls. I know that most of these issues have been addressed in great detail in the fire life safety portion of the project inspector overview, so we are not going to address these in any type of detail. It's also very important to remember that the California Building Code sections 1023.4 and also 1023.5 reiterate that electrical which is not associated with exit enclosures and passageways are not permitted to penetrate the enclosures. Continuing with fire protective measures for electrical installations, all conductors of the same circuit must be installed in the same raceway and also grouped together, which is a topic that we've discussed before, with the focus on all circuits have to be grouped together with their neutral and also tied together in some way with either a zip tie, a piece of tape, or some other such thing, so that individual circuits can be identified. This is reiterated in Articles 300.20a and 200.4b. Another reason that circuits need to be joined together with all of their conductors in the same place is that when you separate conductors, as is shown on the photograph on the right, where all of the grounds are in one raceway, all of the neutrals are in one raceway, And then all of the non-grounded conductors, the reds and the blacks, as you can see on the left-hand side, are grouped together. This is absolutely, completely wrong. And what this basically does is it creates induction between the conductors, which increases heat. So the possibility of overheating when a panel is wired, as is shown on the right-hand side, is definitely a concern and a possibility, and one of the main reasons that circuits must be grouped together respectively and not have their conductors separated as is shown. You could argue that maybe it looks pretty, but it's definitely wrong. We definitely don't want to increase any chance for overheating in a panel by wiring as is shown on the right hand side. Obviously this was fixed before occupancy, but it's unfortunate that it got this far and had to be fixed. We'll now talk a little bit about identification of raceways and cable types for proper use and location, which is obviously a very important aspect of a project inspector's duties. This goes along the same thought process as reviewing materials for compliance with the plans and the specifications. There are certainly restrictions of non-metallic raceways and cables located in plenums. These are areas above ceilings that are used for return air systems. This is detailed in Article 300.22. There are also restrictions of non-metallic wiring methods located in places of assembly with 100 or more occupants, and this is further detailed in Article 518.4a. For instance, 2-inch minimum concrete encasement is required with some exceptions in assembly areas. But again, as we have stated before, many of these issues are design related, and many of these issues will already have been corrected or rectified in the final design for the project. So we want to reiterate again how important it is for project inspectors to inspect electrical construction based on the approved plans. And again, when we say approved, we mean approved by anyone having the authority or the jurisdiction to approve electrical design. To focus a little bit more about how important identification of conductors is in plenums, as you can see in these pictures, there are requirements for exposed conductors in plenums that are serving as return air plenums for HVAC systems. For instance, CMR cable is a communication cable, riser listed, and it's not approved as a substitute for CMP communication cable, which is plenum listed. So the P in CMP stands for plenum approved, and the R in CMR stands for riser approved. This is further detailed in Article 300.22. We'll restate again that this photo on the right clearly shows the designation CMP, which is plenum listed and is approved for plenum applications based on Article 300.22c. And one of the considerations, or two of the considerations, for classifying a conductor for being approved for plenum use is the fact that these particular products used in these materials have low smoke and heat release properties. And that's why they are approved for installation in plenums. It's extremely important to respect the air that is being circulated within plenums to make sure that no noxious or poisonous gases are going to be produced if a fire does break out in the actual plenum for obvious life safety reasons. Continuing with some cables and raceway descriptions, we're going to talk a little bit now about circuit class separation. And although it's a little bit confusing, it is important to understand that standard power and lighting circuits are distinctly different from and must be separated at all times from specialty circuits. And these specialty circuits are identified as classes 1, 2, and 3 circuits. Specialty circuits must also be separated from one another. And the easiest way to describe the difference between these specialty circuits is that they're distinguished based on the power source that is supplying them. For instance, in class 1 circuits, there are two types. There's the power limited, which is 30 volts and 100 volt amps max, and remote control and signaling circuits, which are limited to 600 volts. Safety controlled equipment classified as class 1 if failure of the equipment to operate creates a fire or a life hazard. So it's important to remember that for a circuit to be classified as class 1, the equipment that is operated by a class 1 circuit, if the failure of that circuit creates a fire or a life hazard, it is classified as class 1. And an important to note, or an important distinction to make here, is that fire alarm systems are not considered class 1, primarily since the failure of those circuits do not create a fire or a life hazard. The fire alarm only announces the presence of a hazard, and its failure to operate will not create a fire or a life safety hazard. Continuing with descriptions of circuit class separation, specialty circuits of class 2 in nature are typically low voltage systems. And a good example of this type of system or circuit is a doorbell system, where you've got a 120 volt primary, which puts out 16 to 20 volt secondary, and that's done with a small transformer. Other examples of class 2 circuits are door openers, lighting controls, irrigation controls, communications, accessories, etc. And one of the distinguishing factors in these types of circuits is that conductor sizes as low as or as small as 18 and 16 AWG are permitted, and so is the use of wire nuts or splices outside of conventional enclosures. And the reason that these are acceptable practices is that because of the low voltage, not enough electrical energy is present that would create sparking. The third type of class of specialty circuits is class 3. And class 3 circuits are functionally similar to class 2 circuits, but these have higher voltage and power limitations. The photograph on the right-hand side of this slide shows an improper installation of a variety of class 2 and standard power and lighting circuits in the same box. As you can see, these particular wires here that are grouped together in this insulation, these are class 2 circuits, as are some of these smaller wires in the back. These are control wires. And as you can see, you've got some larger 12 gauge or 10 gauge wires here, wire nutted together. These are obviously standard either power or lighting circuits. And again, the distinction to make is that these standard power or lighting circuits and any of these control wires must be separated from each other at all times. This photograph on the right shows a good example of proper separation of class 2 and class 3 circuits from power wiring. You can see in this particular enclosure that there are 3 separate and distinct areas within the enclosure, and that the separate class 2 and 3 and power wiring circuits are separated as is required. The project inspector is going to be verifying proper box conductor fill. And in order to aid you with your reviews, you can review Article 314.16 and Tables 314.16a and b. And again, we'll reiterate that these tables are used by design professionals to verify the correct design for the systems, and that they can be used by project inspectors simply as a reference when concerns are raised or when questions or red flags go up. With respect to junction box mounting, they are required to be flush with combustible surfaces. But as an exception, they are also permitted to be set back 1/4 inch max from flush for non-combustible surfaces. This is detailed in Article 314.20. For enclosures, they're required to be rigidly and securely fastened in place per Article 314.23. These two photographs on this slide visually represent what we just discussed in relation to the setbacks that are permitted depending on whether or not you have a combustible surface or a non-combustible surface enclosing an enclosure. On the left-hand picture, you can see that we've got a non-combustible surface, which is 5/8 sheetrock, and the actual enclosure that's enclosing the outlet, or the receptacle, is set back 1/4 inch max. On the right-hand side, you can see that this is a different situation. What we have is some sort of wood veneer paneling that's been installed over sheetrock, and the wood veneer paneling is certainly a combustible product. So for this installation, the actual outlet box is required to be flush with the combustible surface. Continuing with wiring methods for boxes and enclosures, it's certainly appropriate for project inspectors to review any number of tables that are provided in the California Electrical Code, such as Table 314.16a, metal boxes, for any details relating to maximum number of conductors permitted in J boxes. You may also refer to tables included in the informative Annex C for conductor fill limitations for a variety of conduit types. You may also refer to California Electrical Code Table 314.16b, titled The Volume Allowance Required per Conductor. But again, remember, design professionals use these tables during their system design phase, and these details will be located on the plan sheets, so it is essential that project inspectors inspect electrical installations based on the plans. As a project inspector, you're also going to verify the suitability of any enclosure locations, meaning damp, wet, or corrosive locations. This information is provided in Article 314.15. Pull and junction bodies and conduit body sizes for conductors number 4 AWG and larger are addressed in Article 314.28. Specifically, when you're using a conduit body for a straight pull, then the length of the straight pull is required to be 8 times the largest raceway diameter connected to that conduit body. The length for splices, angle pulls, or U-pulls is only required to be 6 times the largest diameter of the raceway entering the conduit body. And this is a little bit counterintuitive, the fact that a straight pull requires more space than does an angle pull. But the thought process is, if you're using a conduit body to pull an angle, it's much easier to pull 90 degrees away from the outlet or the inlet on the other side. Hence the reason for the requirement for a longer conduit body length for straight pulls. And it's basically, again, to minimize or eliminate the chance of chafing the insulation on the conductors, or other creating other adverse damage to the conductors themselves. The image on the right shows a picture of an LB where you've got a 2-inch conduit coming into the conduit body, and even though it may look just fine, the code requires that this particular conduit body, as we've just discussed, since you've got at least one conductor in there that is 4 AWG or larger in diameter, that the conduit body is 6 times 2-inch, requiring a 12-inch conduit body here. And again, this is, it's unfortunate, okay, that this was installed, because fixing this is going to be as problematic as is the length from these conductors to the next junction box. But this particular situation is non-compliant with the code, and it did require correction.